to introduce today's presenter, Paul Robichaux. Paul.
Okay, thank you, my friend. Thanks for setting us up, and I want to welcome all of you. Thanks for sharing your time. We'll be together for about 45 minutes. We have a longer update that deals with our activities in providing a web-based interface to the integrity controls environment. But as we get started here, I want to emphasize the fact that during the last year, New Era has been engaged in what we refer to as ICE modernization. That includes not only the integrity controls environment, but also SAE. And the picture that you see on the screen now depicts the operational reach of SAE 17, which can now be IPL directly on the integrated 3270 console of the HMC, untethered now from a specific partition, untethered now from a specific DASD device, gives you the reach to any partition in a Z15 or multiple Z15s, as the case may be, as long as they're accessible by the management network. We have a separate presentation on this. You see here it says June 15th, but I'm sure that's in the rear view now. So it probably will be June the 22nd. My colleague Glenn Bagsby is the expert in this area. And so if you're interested in SAE, have been using SAE, as many people have, you probably want to get in on this particular webcast because it will explain not only how we were able to move SAE into the integrated 3270 console, but some new functionality within SAE that can help you to quickly identify problems that might be preventing a ZOS system from being able to be IPL'd and give you opportunity to quickly recover from that. So look for that coming from Jerry. I'm sure in the next day or two. And as I said, probably June the 22nd. I didn't update my slides, bad boy. Okay, so we're going to talk about the web here today. We sent you an invite that had a sort of interesting picture in it. You see it there on the right-hand side, labeled ICE17 Web Edition. Exactly what is the issue that we're trying to focus on here that makes ICE17 Web Edition intriguing? Well, one of the things that we're interested in, and all utility vendors like a New Era are interested in, is being contemporary. I mean, we want to be a part of the game. We don't want to be left behind. And so getting to the web and having a web interface into our tools is important to us, because it provides direct access into the ICE data space itself, which is big and can be complicated to navigate in a 3270 environment. And also we want to broaden usage of the products, and we want to provide a mechanism to make it inviting for new players into the ZOS world to onboard into ZOS through, and you'll see in just a moment, ZOSMF, and at the same time benefit from its integration with the integrity controls environment, or at least the web edition of that. So our basic problem is to be contemporary, be relevant, broaden usage, provide direct access, and to do it with a web-based environment. So that's our focus for today. So how did we do it? And what are the implications of it from your perspective? Well, the easiest way to describe it is to say we took what we had, let's call that the main task, and we merged it with another task, let's call it the web task. And the combination of those two together is a purpose-built tool by New Era that is delivered as a single encrypted download install file. There's no separate web server. There's no Liberty, no Apache, no Tomcat, no Unix, no nothing. This guy is downloaded exactly in the same way as you have been downloading your versions of our tools for years. The web server is an integrated part of that. It's purpose built. We know every inch of it. There's no generally available code in it. There is no support from GitHub or any of those kinds of things that we are sort of exposed to every day, but quite likely raise issues of integrity and security for the ZOS environment itself. And that security was job one for us as we decided to merge these two together. It'll come as part of your normal maintenance. There's no extra charge for it. You can choose to use it or not. If you choose to use it, using it is quite simple. All you simply need to do is open a socket and allow access to it. And I'll explain a little bit more about how we would recommend you actually do it. When ICEDirect is operational, it has access to 3 domains of information. ICE, of course, inspection reports, resource maps, event journals, interval daemons, to name a few, and to basic ZOS componentry like the health checker and display commands and ParmLab analytics and the IODF. And when we say that, we're not just talking about the running system, we're talking about any system that's in the sysplex where the running system is running. So you can look at all your health checks on all your systems from this guy. You can look at all your IODFs on all the systems from this guy. So it's quite far reaching. And as I like to say, we're just getting started. There are many other aspects of this that are possible now that the platform is in place. And we'd love to hear from you and what your suggestions would be of how we would enhance it to provide you with access to either ICE components or ZOS components or RACF components that you would find of interest. Let me talk just a little bit about the architecture of this, because I think you'll probably get it because you've been getting it for quite a long time. We are running in a ZOS LPAR, okay, in a ZOS LPAR. And the web framework that you see depicted here that comes as part of the download handles the TCP/IP connection, handles the HTTPS services, handles all the web implications, including all the help files and templates and JavaScripts and images and PDFs and other componentry that's necessary in order for it to do its job. And at the same time, it also maintains audit logs. And so this is a completely auditable system. We'll show you some of that as we get into it. Once we're in this environment, once we're in this ZOS LPAR, you can think of this as running as if it were under TSO. All of the rules apply. The server has an ID, both the web server and the ICE server have IDs, and whatever privileges you give them are the privileges that you would give them in TSO. Each user has his own TSO address space, and each of those address spaces is protected by the external security manager in the same way as their TSO address space would be protected if they were logged on to TSO. So this is, in essence, sort of TSO sort of hooked to the web via TCP/IP, or ISPF hooked to the web via TCP/IP, with the same kind of controls and access rights that you would find if you were running directly under a 3270 environment and accessing TSO. Of course, there's a layer here highlighted in the green box that's critically important. That layer represents the connection between the user at his or her browser and that ZOS LPAR. And of course, that layer is critically important in preserving the integrity of the connection between the browser and the ZOS LPAR itself. Setting up ATTLS or IPsec to protect it using Pageant is something I'm sure that your network guys can likely do in their sleep. But critically important, there are settings in the server itself that will prohibit it from supporting strict HTTP constructs so that you can dictate that it will only support HTTPS constructs. As far as the browser is concerned, We have a complete content security policy. We issue a number of different tokens and sconces and cross-site request forgery tokens, just a whole bunch of controls there that we'd be happy to explain in great detail. But again, our goal here was to preserve the integrity of the ZOS environment. If we were unable to do it, to be quite frank with you, this would simply be a non-starter. So one other thing, when we invited you here, we said, how are you going to exploit ZOSMF? And I guess you could ask the question is, how do we plan to exploit ZOSMF? Well, we plan to do it by encouraging you to use it, to encouraging you to put whatever level of security that you need to put on it, and then using its internal mechanisms, link it to ICEDirect. And when you do that, you're going to find that ICEDirect is going to provide you with yet another requirement. And this requirement is designed to defeat autofill, which is equivalent of tailgating for somebody to come in on your user ID and password into the ZOS environment itself. Now, they might be able to do that on ZOSMF, depending upon what your discipline and requirement is, but they'll never be able to do it when they attempt to log on to ICEDirect itself. So with that, let me segue here and go to a ZOSMF login panel, and you can see it on the screen now. And I'll go ahead and log on. I got so many user IDs and passwords, I sometimes forget which one I'm using. Oh, good. 4A, I think. Yes. Okay, great. Now, there are a number of different ways that you can interface with ZOSMF. You can use this iconic implementation that you see here, and you can see there's a little icon down here that says links. And if we click on that, come on, buddy, wake up. Well, maybe not. Let's see what we got over here on this side. We'll use the classic view. That might be better. Okay. So here's the same thing, links in a classic sense. And you can see on the left-hand side here under links, there are two versions of ICEDirect. One of those versions is the local system. That's the one I'm going to log on to. And the other one is ICEDirect Remote. And you can have as many of these as you want. And you can, by using ZOSMF rules, assign roles to different individuals to be able to access the remote system or not, as the case may be, or the local system or not, as the case may be. So you have quite a bit of control here to do it. Now, I'm not in any way want to indicate that ICEDirect could not be accessed directly from a browser while you were on the internet natively. No, that certainly can happen. But the controls that you get if you discipline your organization to come through ZOSMF to reach ICEDirect have great benefits to improve the integrity and the security of the operation itself. And we believe that over time, we'll actually be able to deny service to those that come in directly from the internet itself. Okay, so I'm going to go ahead and click on ICEDirect. And the next thing we're going to see is a panel. Now, this is going to require me to re-authenticate with ZOS. Different password in this particular case. And remember, each one of these systems could be potentially different and require different logon authentication. As this one does. Now, here's that additional step that I mentioned earlier. We call this MFI, multi-factor ICE. This is a form of multi-factor authentication, if you would. I as a user, you as a user, whoever is a user. In this instance, the way this is implemented, would have registered with ICE a PIN And that pin would be secret to them. They would be the only ones that would know it. It's stored in an encrypted vault, much like you would store external security manager passwords. And the user has to know what that is. Now, what's good about this is that this prevents the browser from being able to remember what your user ID and password are, because each time you come in, that token material is going to be different. So tailgating in on somebody, not possible into ICEDirect. Robots getting into ICEDirect, not possible because of the fact that this multi-factor ICE authentication is a challenge that the users have to meet. So I'll go ahead and type mine in. Okay, so now we see on the screen what we refer to as the ICEDirect frame set. Okay, so these are iframes. They're sandboxed for security purposes. There are 3 of them. The one to the immediate left is called the sidebar. And so you can scroll up and down it. And what you see here are application names. Now, these application names mirror the same names in a 3270 environment. So you can perform many of these same tasks in the 3270 world as you can here in ICEDirect. These little life preservers, these are help panels, okay, that give help and advice as to what to do and when to do it. If you don't know what an application is, you can click the question mark next to it and you'll get an explanation of what it is. You can go ahead and close that. This is a more personal kind of implementation than you might find in a 3270 environment because there are different roles that people have to play. For example, let me just show you this. ICEDirect supports prime administrators, so that's one role. It supports auditors, that's another role. And it supports general users, that's another role altogether. And each of them have essentially 4 paths that they can pursue in their use of ICEDirect. They can be working with it, they can be doing analytics with it, they can be doing control activities with it, and they can be doing web security with it, as the case may be. Administrators have access to all that. Auditors have access to some of it, can view most of it, but can't change anything, can't change any settings per se. And general users can work with ICEDirect and they can use it for analytics, but they have no control over the activities and they have no access to web security activities. And so those are the different kinds of roles that we see here when we click on My Who. Who am I? I just logged on. Who am I? Did my role change since the last time I was here? No, I'm still a prime admin. Good. ICE is collecting lots of information about each of these individuals in terms of their access to control data sets, their usage of commands, inspections, all kinds of things that are going on in the integrity controls environment. And it might be interesting for you as an individual to know what we know about you. Click on My Hiss, and it'll give you a query panel that allows you to specify a date to start with, or an end date, or don't specify an end date and you'll go through the current date. And you could build individual little reports about yourself. So if I want to know everything that's been going on about me that's been collected in ICE since the beginning of June, I just hit submit. Now I have 2 choices. I can see my results as a text document. So you see the little document over on the left, or I can see my results graphically in the form of a donut. So I chose the donut because I just like donuts. I don't know what else to say about that. When it pops up, it's going to give us Now we can slide, we have multiple sliders here, so we can slide this guy up so we can see them all. It's going to tell us exactly what it knows about us. Now, I've been logging on and logging off for the whole month, and you can see I've logged on 158 times. It allowed me in. And I failed to complete things correctly 14 times. And that could either be because ZOS denied me or because ICE multi-factor authentication denied me. If I click on the 14, I'll get a report. Says, okay, here's all of those 14 items. And then I can pick an item. This is a push down stack. So the most recent one is on the top. Note that I haven't failed today. I feel really good about that. My last failure was yesterday. And you can see what ICE knows about me, what the integrity controls environment and the journals themselves know about me. So if I had been busy editing a bunch of control data sets, changing some system settings, whatever the case may be, this guy would have captured that. All that information would be immediately available to me. When I logged in, I told you that I had to have a private PIN. So my MFI allows me within this environment to update that PIN if I want to. So I can put in my old PIN, put in a new PIN, confirm that PIN, and go ahead and update it. But I also have different techniques that can be used if I choose to use them. One other technique is to abandon the use of the PIN itself and to create a full pass ticket sent by email to me or to my phone as I attempt to log in. So when I make that attempt to log in by authenticating with ZOS, if I were to select this option, an email would be sent to me or text to my phone that would contain an 8-character PIN that or a pass ticket that I would have to enter into the panel in order to be able to continue my work. It would change each time. There would be no way to predict it. There'd be no way to intercept it. It is good for just a few minutes. In addition, you can also designate that someone else receives that pass ticket, and you would have to communicate with them, probably via phone, to get that ticket and retrieve it and use it. Now, those controls seem somewhat stringent, but they are the same types of controls that are available with MFE, multi-factor edit. Multi-factor edit is the answer to the question, how could you protect specific resources from people who are already authorized and in the ZOS environment? It is an answer that we are persuaded to fulfill because NIST is now pushing what they refer to as a zero trust architecture, where it's not just the perimeter of ZOS which is being protected, but it's the individual resources within them and the mapping of those resources through the control journal is absolutely spot on for what their recommendations are. So if you haven't gotten into MFE, multi-factor edit, it's likely something you'll want to pay attention to. Now moving down to inspections, we'll click on my BGN. Now my BGN is the background, and the background inspector is set up with the VTAM application currently. We expect to be able to move that to the web in the future. It builds and stores and maintains an inventory of Sysplex clusters. These are data sets. And we can look at that history if we want to. I'll just click on history here. I asked for 10, and you'll see how many there are. I asked for 10, but there are actually 95 of them. So I can go all the way back in history if I want to. They are in a push down stack. So the last one on the first one on the top is the last background inspection that was run. I can select one like that, and then I can ask it to disaggregate that cluster into its separate images and present the results to me in the form of a dashboard. And you'll see that this will take a few seconds. I'll show you a little performance meter here in just a moment when this finishes, so you can get an idea of how long that actually took. So here's the performance meter down here at the bottom, and you can see that it took 14.59 seconds. 54% of the time was spent in ICE, that means in ZOS, and the other 46% of the time was spent in TCP/IP. It's a big report. It's 155,000 lines long, approximately, and it's now been broken down and presented to me in this fashion. So I can get directly to each one of these images, and if I choose to, I could say, hey, I'm interested in these errors. I'll click on those two. Takes me directly to those two errors. It says, hey, you got these two guys. What do you want to do? I want to go see. I click on this. Now, you'll notice it says we have two errors, of which two are unique. Now, I'll show you a little bit later why that kind of classification might be helpful. I'm going to click on 14080. That's the line where the error actually appears in those 155,000 lines. And it points out to me that this is the problem right here that it was complaining about. We show 50 lines above and 50 lines below in order to give perspective to what it is we're reporting in case there's something that has happened above it and perhaps maybe something that might be happening after it that could be of significance or importance. And so all of this is available here. Well, we can go to the detail report. I'll click on that. This is a finding. And you can see now we have two errors. These are the two errors we looked at. But we have 31 warnings, of which two are unique. So most of these are all the same. And in this particular case, they have to do with data set protection. And then we get down to the bottom and we have a unique one. We have something that's going on in our serve auth inspection process. And then we have notices, and then we have informational messages all the way down to the bottom. This took 7 seconds in order for us to be able to do it. It analyzed 173 messages, of which 12 turned out to be unique. So you can continue to probe this as you see fit. But what I'd like to do now is do something that I think most of you do, which is use ICEBAT-A. So ICEBAT-A, SAE, my check, these are all batch jobs that run inspections in one way or another. Now, you could do a catalog search. If you have a constant defined naming convention that's defined to the system, and you can see one up here. In this case, the catalog search would look for all the data sets that have the high-level qualifier ending with ICEBAT-A. It would wildcard the system name and then put .log and go look for all of those, and it would return them all if it could find them. It might not be able to find that, but if you wanted to do an alternative one, you could stick that alternative naming convention here, as long as it has ICEBAT-A in it, and as long as it has .log on the end of it, you'll be cool. Or if you have completely no plan to do anything like that, you can set up a worksheet. Now, my worksheet is 5 rows big, but you can make it as big as you want to or as small as you want to. I've already set mine up. I'll submit it. And it'll come back and it'll give me another dashboard of those 5 ICEBAT logs that I happen to be tracking. And you can see them here. Here's one that I ran earlier today. You can see the date and the time here, 6/17 at 8:32. We could go and look at the results. We've already been into the results, so we don't really need to go back there. But there's a different view that can be taken here. This could also be taken in the background report dashboard as well, that we call the IPL path. And let me go ahead and click on that. When we look at the report and the findings, all we see are errors, warnings, notices, and certain informational messages. We don't see everything. But when we go through the IPL path route, we see it all. We begin with the NIPS processing. These are the items that are shown here in yellow, which segues into IEA processing. Those are the items that are shown, the members that are shown here in blue. And then once we have a functional ZOS and we have an opportunity to load the subsystems, we see them here showing in green. Now, the same errors and warnings and notices are reported here. The little icons next to the member name tell us exactly what happens to be going on. Now, the way we see this particular presentation is the same way that the members are processed or would be processed by ZOS. But it might be more helpful to sort this list by those members that were last updated. So in other words, put the member that was last updated on the top of this list so I can see if something that might have been changed recently could be causing a problem for me. Okay, so now we've sorted the list and we can see here that we have a BPX PRM BP member that was changed on April 15th. That seems to be causing a problem. So let's go take a look at that guy. So all we have to do is click on the little icon and it'll go get it. Now that go get that I just mentioned is essentially go get it out of the inspection report. So now we're looking at the lines in the inspection report for this particular member. And what we see is that there isn't anything particularly wrong with the syntax or constructs of the member itself, but there are referential integrity problems because the data sets that are defined here don't have adequate profile protection. And so all of that is laid out for us as well. Now, if we are using both the control editor and image focus, what we could do now is do a wildcard search against the journal to see if there are any BPX PRM
Okay, so
members.
how do we show this in our,
Well, I'm just putting
Okay.
holiday.
So
well,
here,
yeah, that's what
so
we need
here
to do,
we
but
see all of the
boy, they're gonna
BPX
be upset.
PRM members that
Because
are
that
known
blows the whole
to
salary
the
structure.
control journal. And here we see the one that we are interested in, BPX PRM BP.
I know it.
Click it,
Okay.
it'll produce it for us. Those items that are shown in blue are backups.
Of course, if he doesn't sign it.
Those items that are shown in green are event journals. And so we have the complete provenance of
Go
this
check your
member
email.
maintained by the control editor. Now, clicking on one
That's
of these,
fine. Yeah. Nope. I'm avoiding looking at things till after I get done with my meeting with Tim.
Paul, excuse me, I'm going to interrupt for a second. If you are not muted right now, it would be real helpful for the rest of our attendees so that we don't get any background noise. Thank you very much.
okay, so now we see what the content of that particular member is in the control journal, what changed that impacted it, and what that member currently looks like. So this is a connection directly between image focus and, see if I can get back here, and the control editor itself. There are filtering capability here for users. Let me get back here now. Now, we're looking at the control journal on this side, but if we go over here on the other side and we click data set member listing, then what we're looking at is the equivalent of a 3.4 list under TSO ISPF. This is the actual member as it currently exists in the ZOS system. So we can see that, we can determine what it is, we know. Every time I go up there, the sharing menu comes down. Okay, now let me try one other thing here. If I don't click this and I hit member list, now this may take a bit longer because it's now going to do a complete 3.4 list. So here's that list. There was 35 members and it took 9 seconds. And again, this may be of interest because it's done alphabetically, but if I click on sort by last date, we'll get an idea of which of these was the last one to be impacted. And we can see here that those members and the way in which they're impacted can be easily essentially determined from the list itself. I'm not sure why. Oh, here we go. Okay. I'm just a hair too high there there we go. All right, so that's the IPL path view. Now, lots of you use the workbench to run ad hoc inspections. We can do the same thing here. We can launch the background or launch the batch job immediately from here. You may want to change this configuration. You can do that if you give us the proc dataset name. We can't figure out the proc. You're going to have to tell us where the proc is. We'll go find the proc, and in that proc, the only thing that it can execute is a proc that is actually named IceBat A. Can't execute anything else, just that one kind of proc. It'll give us all the settings that are in the proc. And so we can change them here if we want to turn member display off, reports off, we want to turn JES on, TCP/IP off, whatever the case may be. We can do all that here. And then we can update the proc. And then we can launch an inspection, just like we would if we were in the workbench. Of course, we'll have to wait a few minutes for it to complete and go back out to our little worksheet to select it. But I think you'll probably find this to be equally handy for doing ad hoc inspections of images that you have set up that are running for you. Now, this is all pretty, what should I say? This is all pretty handy, but you may not be coming in here all the time. And so what you might prefer to do is set up an interval detector. And what you can do there is give it a date and a time, or excuse me, a time, tell it what interval you want it to run at. So mine's running every 12 hours. And you could, if you chose to, you could send yourself a copy of that report via email. Or you could send several people copies of that via email by just listing their email addresses here. But in some cases, I went up too high again. In some cases, email is not an option or a preferred option. So what you could do is just set it up and let it run. And then when you're ready, come here to pick up the last report that was run. And this is the report. This is the actual email that you would have received. These links would have been hot in the email itself. You would click on one, like let's say this one. And you would launch directly into the findings. So if you want to send it by email, you can, but if you don't want to send it via email, you don't have to, and you will always be able to get to the last execution uh, of a set of reports. Remember, there were 3 of them there that were defined, and those definitions are based on these little check marks here. Okay, let me go to reports. It's kind of an interesting one. Again, this is, we're looking at BAT, but these same reports are created in the background. They're intended for our judges, okay? That's our little icon we have there. These might be auditors, they could be risk managers, they could be the boss, they could be you wanting a report of some specific kind. For example, you might want a report that deals with the prevailing keywords out of IEACIS. I'll go ahead and click that. Now, these are doing quite a bit of work. So they'll take, this is not something you do every day, obviously. This is something you do when you want to do it. And you can see what we've done is we've taken every possible IEACIS keyword and we've listed them here and then indicated which of them is actually a keyword that resulted in a member that we chose to inspect. And so, for example, if I come all the way down here and I click on PROG, I'm not going to see just one PROG member. I'm going to see all of the PROG members that were linked out of IEACIS. And I'm going to see the collective finding for all of those members taken together. Okay. So lots of additional detail that you can do there. If you have, if you're using a browser, one of the things that you could do is go to print. You could say, I want PDF. I want to send it via email. It'll convert it. And you could send this off to someone and say, hey, take a look at this. I think it's important. Maybe you're sending it to the auditor. Maybe who knows where you might be going with it. But again, there's specific identification here of the image that was inspected, unit address, load parm, IODF volume, the whole works. The image, the name of the LPAR that was inspected, that is the name that was assigned by you to the inspection process itself, and the specific report log that this information was extracted from. So all of that obviously is available and could be used to send an email to somebody if you chose to do that. There are a lot of other reports. They all have a similar kind of look and feel. Anytime you want to, by the way, you can clear the lower frame and it'll get rid of whatever is in there. I fail to point out that every time you make a selection from the sidebar, it always makes a notation of the selection with a little gray box. Okay, so that's something that's there. BAT, ICE, and my check are similar. Let's go to the health checker real quick. In the case of the health checker and in the case of the IODF, the process is to issue a display XCF command to determine all of the images, all of the LPARs that are in the sysplex that the running system is in. And if there are more than one, I only have one here, but if there are more than one, they would be populated in this panel and could be selected individually if you wanted to, or in the case of the health checker, you could select all of them and run an analysis that compares the health checks on each system against each other system so that you could determine the differences that would exist between them. I've just got one system, so I'm going to go ahead and click, go ahead and get the health check findings. Again, this is not something you probably do every day, but you can, just like you could with ICEBat, you can set up an interval detector for this as well. So you don't have to come here. This guy will do it for you and send you an email or build a report, as the case may be, and then you come pick it up. So we can see here what this guy has been able to find. He's got a few things to report. You can see all of the names of all the checks that are here. There's literally a couple of hundred of them, I believe, in this whole process. This took 16 seconds to interrogate the system and the health checker and say, give me what you got. If I click on one of the check names, it'll go off and get the results of the check and bring it back and display it on the screen. Now, there's one caveat here. By the way, there's some help panels here. There's one caveat here that the descriptive information that you see in the check information that was returned when I clicked on the check name, that information applies only to the running system. It does not apply to the remote systems. Why is that? Because the health checker won't cough up that information from the remote systems. It'll cough it up from the local one and we can display it, but we can't get it. We can get the check status from the remote systems, but we can't get the actual report. I guess the data is just simply too voluminous for them to want to move it that way. So that's, God, I keep doing that. Come on. So that's the health checker. Let me go to MyIO because I'd like some help from you if you're at all interested in what you see us doing here. Now, again, I ran XCF, I got the systems. Now what I'm going to do is I'm going to do an iOS display to get the IODF data set that actually is running SAL1. So that's what it's doing now. It's disaggregating it and presenting it again with very specific information about what this particular system's eligible device table, configuration ID, what its actual IODF is, what volume it's on, where it was, what it's on now, just a whole bunch of data. And it tells me what the real IODF is. That's this guy over here. But I don't want to work with the real IODF. I want to work with this one, which is a real IODF. This one over here is an IODF running on as a VM guest. So the only thing it has is the OSCP. It doesn't have an IOCP or an IOCDS. So I want this guy over here. And so I'll say, okay, I like you, and I want to do an IOCP analysis. So I click it. Now this might take 15, 20 seconds. There are two Z15s in this IODF. Each has 6 logical channel subsystems. Each of those logical channel subsystems has 15 LPARs. It's classifying all that, pulling out the names, and now it's presenting it to us. So you can see here the identification of the actual KEC itself. This is a Z15. You can see each one of the logical channel subsystems, max devices, etc., what LPARs are in them. Lots of stuff we can do here. I'm going to go down a bit because there's a good example of something I'd like to show you. It's this one down here. So this is logical channel subsystem 2 in the second Z15 that happens to be in this IODF. Now, if I click on this little spider looking thing, these are supposed to represent chipids. I click on that and it's going to go off and figure out all the chipid relationships between all of the logical chipid names and the peaches and give us a heat map that shows us the interrelationship between them. So let's take a few seconds to perform that task. Don't give up on it. It will complete, as they say. So you can see the little heat map in the middle here. And let me try to explain what this is. First of all, the channel subsystem that we selected was 2, and that's why it's shown in white. Other channel subsystems that are supported by this chipid, in this case 00 or 130, are 0 and 1. But they're not what we selected, but they're interesting to know about them, is what I'm saying. And so they're shown in black. So the one we wanted is in white, and the one that we didn't want, but are part of the process, are shown in black. Now, I can select one of these, like this one here, and it'll go off and it'll figure out which LPARs are in which of those logical channel subsystems. And it'll highlight it for me by saying, again, you didn't pick the black one. You didn't pick LC. You didn't pick channel subsystem 0. You didn't pick 1. You picked 2. That's why we highlighted it for you. And here you are. So CP 521 is the processor that is on the partition, on the access list and the candidate list on this particular chiplet. Now, if we back up and we find another one, let's see if I can find one that might work. Sometimes they don't work exactly the way I want them. That's why I need your help. You probably know more about how they're supposed to work than I do. This is a not part construct. In other words, in this particular case, we're not looking at a configuration that says partition or part equals a chiplet. We're looking at something that says not part equals a chiplet. We changed the color, made it red to make it highlighted. But then again, we did the same thing. We looked at all of the logical channel subsystems that are defined by that chiplet, and we pulled out those LPARs that are associated with them. But we can see here that on logical channel subsystem 2, on chiplet 92, we don't have any LPARs that are named there, but we do have some other ones. At the bottom of these reports that you're looking at now is always a legend that allows you to look at the actual raw data that is being processed by ICEDirect in order to give you an opportunity to challenge us to see whether or not we've done things correctly. Okay, so that's the purpose of this stuff down here at the bottom. Okay, one more thing. I'm going to go back here. Okay. So it's interesting that it's like this. We can sort it. So we can sort it by chiplet. Again, this will take probably 20 seconds. And I plead with you, if you have any interest at all in what we're doing, and you can share your IODF with us, we would love to get our hands on it, okay? Because the more of them that we have that we can run through and test, the better off we're going to be. So now it's sorted. You can see some don't have chiplet assignments. Those guys have question marks on them. Some have virtual chiplets. We identify those as well. But here we now have them sequentially with the lowest number on the top. So we're going ascending, if you would. Same functions, everything exists. The other thing that we can do here, if we want to, we can check to see if there are any duplicates. Let's go to 23C and see what that guy's all about. And we can see now that there are 4 duplicates of 24C on address 33, 3B, 3F, and 37. And they're supporting different channel subsystems, but they're all using essentially the same type. So if we click on that, we can see what LPAR is associated with that, and back up, do it again, whatever the case may be. Again, our plea here is that if you are at all interested in what we're doing and you have an IODF and you can share it, please contact technical support and let them know that you can do this. A couple of things before we get to the poll. I want to encourage you to go out to our YouTube site. There are a bunch of ICEDirect YouTubes out there. I think there are 12 of them now at this point in time that are probably on the average about 15 minutes long, worth taking a look at, particularly if you're interested in what we're doing. Final point, everything that we're doing is being done under the watchful eye of the professional pen testing organization NetSpy from Minneapolis, Minnesota. They are testing our web presence, determining whether or not we are truly following the appropriate protocol to protect that pinhole that we're opening up into the side of ZOS. For your auditors and for your risk managers, there is a complete description, real-time description of our browser policies that are available that expose the number of different tokens that we are using in order to protect access to ZOS. The actual session token itself, a cross-site scripting token, and a nonce token for the graphic inline JavaScripts, which generate pie charts, bar charts, and other kinds of charts that are in the system. Everything is detailed and explained, and if you need further explanation, and in some cases that might be necessary, we are happy to provide it. And we're also happy to provide access to the ongoing reporting processes that are being conducted by NetSpy. Okay, so Jerry's got a poll. I think it's worthwhile paying attention to. Really what we're interested in is where you see the future going. For young people, for broadening use in your organization of vendor tools, what's it going to be? Strictly on the browser, perhaps the browser, but through ZOSMF, or are you planning to stick with 3270 TSO VTM CICS? Let us know what you're thinking. We really would like to know. Okay, Jerry, I'm done. I want to thank everybody for coming out and meeting with us today, and assure them that if they need any additional information, we can provide it.
All right, thank you, Paul. And I too want to thank everybody for joining us. I do have the poll out. It's one question. People are clicking on their choice right now. We'll share that information with you in a half a minute or a minute or so. And if you joined us after we started, I do want you to know that I'll be sending out an email later on with a copy of the slides that Paul just used. And I'll include a link to our event calendar so that you can check out our other webcasts that we do have scheduled yet in the month of June. At this time, it looks like browser interface is the preferred method for future ZOS tools, followed up by ZOSMF exclusively. And in third place, it's 3270 TSO VTAM CICS. So browser interface right now, Paul.
Okay.
Paul is a heavy leader.
Well, you know what? Thank you so much for sharing your thoughts with us on that. It's very helpful and encouraging to hear that. And again, I stress that if you're at all interested in what we're doing and you have an IODF that you can share, we could really use it, and we would be very happy if you could send that along to us. That would be just enormously helpful to us. Okay, I'm done. Thank you, everybody. I appreciate it.
All right, thank you. Watch for an email coming from me shortly. This ends today's presentation. Goodbye, everyone.